Hi, welcome to the channel. Thanks for watching. This video is all about adding a waterfall display to any radio from VHF all the way up to 70 SEMS. There's a backstory involved which I'll explain. Hope you find the video useful. So regulars to the channel will know I enjoy my portable contesting. I take part in 6 metre, 2 metre and 70 SEM contests using my FT991A. I've got amplifiers for 70 and 2 metres. It's been noticed that I've got a wider signal than I should have on 70 SEMS, and here you can see a trace of that signal. Thanks for Rob and Nick, local amateurs, with the help for working on this. You can see here there's quite a lot of product either side that we don't want. By comparison, he's a very modern VHF UHF rig at 7900 at ICOM. Much narrower signal, you can see, and the trace overall is much better. And again, by another comparison, we tried out a Kenwood TS-2000, an older rig, but with a good reputation for VHF and UHF. And you can see again, the signal is a lot cleaner. So this is the addition to the shack, or more accurately I should say the mobile station. So this is a Kenwood TS-2000, so a HF 6 metre, 2 metre, 70 SEMS transceiver. Standard model, it's not the X, the X has 23 SEMS. So this is primarily to be used on 70 SEMS, but I may also use it on 2 and 6 in a contesting scenario from the car. So it's a lovely rig, it's in great condition, works fine. The specs are 100 watts HF output and 6 meters and 2 meters, and 50 watts output on 70 SEMS. So I'm looking to use this, as I say, portable in the car to replace the 991A contesting. So first issues I've got are I need to make sure it all wires up correctly, patch lead lengths and so on, and fitments, because the back of the 91A is different to the 2000 when it comes to sockets, and I'll just show you that now. So this is the rear of the 2000. On the 991A there's a HF socket, an SO239, and there's a VHF UHF socket, an N plug, a female N, whereas here you've got two HFs. The 2 meters is a SO239 and the 70 SEMS is an N female. If this was a 23 centimeter rig as well, there'd be another connection there for 23 SEMS. So I just need to account for those different changes in my patch leads, and also the PTT, which comes out of there for connecting to the amplifier. On the 991A is just one connection. On the 2000 it's multiple connections depending on what band you're using, so 6 meters, 23 SEMS, and there's a 70 SEMS one red, and so on, 2 meters white. So that goes into there and can key different amplifiers or devices. So that's a quick run round of the 2000. A very, very nice looking rig, and hopefully a great addition to the portable station. So like most modern rigs, the 991A has this waterfall feature, which is great for seeing what's happening on the band and is really useful in a contesting environment. Whereas the 2000, slightly older technology, no worse, but doesn't have the waterfall feature. It does have a band scan feature, which is quite simple and not really good enough for sort of faint signals on a contesting band. Now, the project is to get an SDR output from the 2000. You can buy kits which are IF tap boards, where you break open the 2000 and basically tap various IF points depending on which bands you want to use. And that's one of the complications. The 2000 has multiple IF points for the different bands. And also some of the IF points also give you a very narrow bandwidth, which could prove a bit annoying. and not much use. So rather than crack open the 2000, what I'm going to do is use this MFJ. Now this is an MFJ SDR switcher box. I'll just put it down there and just show you what it does. So this is an MFJ 1708B SDR, and there is an SDR S model, and there are models that don't have SDR on the end. So for this application we need the SDR version. And the difference between the SDR and the SDRS model is basically the SDR has an SO239 here for the SDR connection, and the SDRS model has an SMA there. This was the only one available in the UK at the time I was starting this project, so I've got the SO239, so I just need to add on this PL259 SMA converter. So just a quick tour of the MFJ. Basically your transceiver plugs into there, your antenna goes into there, and your SDR receiver comes out of there. There's a relay switching mechanism inside that has RF sensing, but you can also use PTT switching, so you can switch the MFJ from your rig's PTT there, and you can also key up an additional amplifier from that output there. There's various settings. You can adjust the delay, and inside you can change jumpers on the board to make it do different things. I'm going to use it PTT, which gives better performance. There's no relay delay, and also the RX on 70 will be more sensitive. So the advantage with this box is you don't have to break into your rig, and it'll work on any rig, but also you're getting the benefit of the RX coming in from the antenna both to your transceiver and to the SDR at the same time. So this can go off to an SDR box and some sort of computer, laptop, or a Raspberry Pi, say, and give you a display of the band, and at the same time your rig is doing its usual receive. Now this model will handle 200 watts. It's in a nice little plastic case, not very heavy. That'll take 200 watts, but there's no need for it to be on the output of the amplifier. It can be between the rig and the amplifier. So here where we see the antenna connection, that can go off to amplifier, then to the meter, then to the antenna. So the MFJ only needs to take the lower power RF from the rig, not be on the output of the amp. So I just need to see how it fits in with the station. So just to get a feel of how all this is going to go together, I've mocked up the 77s station. So here we've got the 2000. The output of the rig goes into the MFJ, into the transceiver socket. The antenna socket in this case feeds the amplifier, and then the amplifier output comes round into the meter, and then the antenna would be connected there. The benefit of having the MFJ in between the rig and the amp is that this amp, and my 2 meter amp as well, has a built-in preamp for receive. So the MFJ being on the rig side of the amp means that on receive we're getting the benefit of the preamp feeding both the SMA socket and the rig receive. So the rig benefits from the preamp, and the SDR is going to benefit from the preamp, which is quite critical. One issue I've got here is currently the PTT lead goes from the amp to the rig. I now need to jump across to the MFJ, and then the amp needs to connect to the MFJ as well. That phono lead isn't long enough to reach there, so I might extend that lead, or I might actually bring that MFJ around here, face the rig, and just have some short patch leads, and then use these existing phono lead. So I just need to understand how that's going to work. I'll try it out with the 2 meter amp on as well, just to make sure that everything's going to be fine. So that's the idea. Just need to now make up some patch leads. So I'll just show you a receive only test first. This is 80 meters. The VHF UHF bands are quiet, so not a very good demonstration of a waterfall display, so I've chosen HF. I can't do a transmit test on HF because the PTT switching out the back of the 2000 is different to the VHF and UHF bands. So this initially is a receive only test, and I'll just show you the connections. So we've got a patch lead coming out the back of the rig into the MFJ, and then antenna plugged in direct. And you can see this power were lit up, and the power lead, and then on the far side you can see the SMA lead going to, in this case, an RSP1A SDR receiver. Ignore the foil, that's from a previous experiment. The RSP1A is screened, so coax to a SDR receiver, and that goes via a USB lead to an old laptop running SDR Uno. And here we can see the waterfall display on 80 meters. We're on 3.759, you can see at the top. And here's the band, the SSB signals, all the usual things you'd expect on a waterfall. If I can just turn the volume up, left-handed, and you can just move around by clicking the mouse or using the scroll wheel. Just turn that volume off again. So there you can see the band, so that could be 70 sems band or 2 meters, which is what I'm going to use it for. So with the waterfall displaying on the laptop, we've got the rig here, can be on any frequency, doesn't have to be the same frequency as the SDR. So there, 3723, but on the SDR we're on 3751. So success. That's the received test, and now to do an RF PTT switching test. And in terms of adjustments and options, I've removed Jumper 2, so I'll be using PTT switching. If you don't need RF switching, removing Jumper 2 improves the sensitivity on VHF and UHF. And I've got Jumper 1 set to unground, so the amplifier unkeys when we're into receive. So they're the two easy changes inside. So this is a 2 meter full test. We've got the rig, amplifier, switch box, meter all in line. Here's the SDR view of 2 meters. I can zoom in, which I'll do when I'm just using SSB, but there you can see the SDR picking up the signals. So the setup we've got for this test is, here we go, the rig, and we've got the rig into the MFJ into the amplifier, and the amplifier into the meter, and then the meter out to a core linear. There's the RSP1A connect again. We've got PTT leads going to the amplifier into the auxiliary connection on the MFJ, and we've also got the PTT lead from the rig going into the control connection. And if I just move off that frequency and just keep quickly, you should see the lights change hopefully down there. There you go. So we've got instant PTT switching of the amplifier. So success. So here we've got a signal on the band at S3 without the preamp on the rig on. If I turn that on, it goes full scale. Likewise, the amplifier preamp. So as a test of pass-through attenuation, that is S3 with the MFJ in line. So now I'll disconnect the MFJ and go straight into the amplifier and see what the difference is, assuming that signal's still there. So just waiting for that signal to come back. It's an echo link repeater. This is the rig straight into the amplifier. There we go. So S7. So we've dropped from 7 to S3, and that's with no preamp in. So if I turn the rig preamp back on, if this comes back, that'll be full scale again. So there is some attenuation as the MFJ splits the signal for the SDR and the rig, but with rig preamp on, and also I've got the amplifier preamp, I think I'm well catered for, so I'm quite happy with that. Just need to try it out, and there we go, full scale with that signal. So just to show the attenuation on the HF bands, the VHF and UHF are quite sort of specific. So we've got the RSP 1A back where it belongs, being a Panadapter for the 5000, and here we've got a station that's generally around S9 plus 10 on 20 meters. So I just need to now put the MFJ in line and just see what the difference is. So here we've got the MFJ in line now. We've got the off-center fed dipole into the MFJ, which isn't powered on, it doesn't need power, and then a patch lead into the 5000. And that chap was still S9 plus, and still strong signals on the waterfall. If he'll come back on, I'll just show him again. There he's back. So that's with the MFJ line. So no noticeable attenuation. Still as strong as he was. So you've got some signals on 15 meters, and this is with the MFJ line. So I'll just switch it out now. So this is with the antenna straight to the back of the rig. So here again on 15 meters, I've left the waterfall running on a big display. So the top is with the aerial straight in the back of the rig, and the bottom feed coming up is with the MFJ. So very little difference, I think you can tell on these low bands. So really happy with that. So all the tests show this MFJ SDR switch box is a good accessory if you want to have a waterfall display on your rig. I'm going to use it portable VHF UHF contests. I've used the TS-2000 once without the waterfall display, so I'm looking forward to having a full band display while I'm contesting. Hope you enjoyed the video. If you like this sort of video, then please consider subscribing to the channel, and then you'll be informed of any new releases. 73.